Hello and welcome to Experiment 3, which is our Kinetics lab, and I'm going to be going over the pre-lab before we get into this experiment. So the purpose for this lab is to investigate the variables to see how they affect the reaction rate. And going into properties and safety for the compounds oxalic acid, potassium permanganate, and water. Oxalic acid is a white odorless powder that is stable under normal temperatures and pressures and has a melting point of 101 degrees Celsius. And then potassium permanganate is a dark purple to bronze color, and it's odorless and is in a crystal state and is stable under normal temperatures less than 150 degrees Celsius, which is its decomposition rate. And it has a melting point of 240 degrees Celsius. And then, of course, lastly, we have water, which is a colorless, odorless liquid, which is stable, and it has a boiling point of 100 degrees Celsius. Now going on to our pre-lab questions. For the first question, it talks about the concentration of reactants and how that affects the rate. So the concentration of the reactants affect the rate because more often than not, reactions continue faster with an increased concentration. The higher the concentration, the more frequently the molecules will collide with each other. Then question 2 asks for how the temperature changes your reaction rate. So the temperature affects your reaction rate by increasing the kinetic energy of molecules, which makes them move more rapidly when you increase it. If you decrease it, then the complete opposite happens, and that means there will be less collisions, and so your reaction time, it will take longer for your reaction to complete. And then the last question, how does a catalyst affect your reaction rate? A catalyst affects the reaction rate by making the reaction require less energy to occur, which would fasten your reaction rate. It would make your reaction rate go quicker because it ultimately makes it so that it requires less energy for your reaction to occur. And that is our pre-lab, and we'll see you in the experiment. Hello, we're about to start reaction 1 for this kinetics lab, and as you can see, I already measured out 4 milliliters of my 0.03 molarity of potassium permanganate and also 4 milliliters of the 0.6 molarity of oxalic acid. And so we're about to start this reaction, so all we got to do is just pour our oxalic acid at 0.6 molarity into our other test tube. And there we go. And there's the first pour, and I'll check back to show you whenever there's significant change. Okay, hi, I'm back at the 3-minute mark. It has changed significantly. At first, it was almost wine, turned into a wine red hue, but now it's this, I can't even explain the color, this orange amber color. And this is at the 3, close to 4-minute mark now. So yeah. Okay, so we've reached the 15-minute mark, and the color change of the solution is looking a lot more yellow than it did before. And is it looking, I mean, it's always been clear, but it seems like it's getting closer to that colorless clear state than we were just a little while ago. So that's the time. So we're at the 26-minute mark, and our solution has become very clear. It used to be at the 22nd minute mark that it was this like champagne color, but it's getting so close, but it's not close enough. If you compare it to water, it's still not as clear. So I will give it a little bit before we go it might need just a minute or more until it's completely clear. Yeah. Okay, so it finally became clear, and right off camera what I did was record the timestamp, which is 36 minutes and 41 seconds. It became the clear that it is right now, and the final temp was 25 degrees Celsius while the initial temp was 26, so it didn't really change too much. But that is the end of reaction A, being our standard so that we can compare it to the other variables that we'll add to it to see if it changes the reaction rate a significant amount or not. So. Now we are moving on to reaction 2, which deals with having, what was it again? 2 milliliters of potassium permanganate with 6 milliliters of distilled water, and what was it again? And 2 milliliters of our oxalic acid, I'm sorry. And now we are going to mix them and start our timer and record the initial temp whenever it just mixed. So our 2 milliliters of our oxalic acid has been put in, and at the beginning right now it's this purple color, but now let's gonna start that timer. Okay, so we have reached the close to the 10-minute mark, and our solution with potassium permanganate and oxalic acid is a much more pink, almost magenta type color, and I'll zoom in and show you. But yes, at the 10-minute mark, it's turned from this purple to this almost like magenta pink color. So we're at the 11-minute and 30-second, and this is slowly starting to change. It was at this really dark red, but now that I can see towards the bottom, there's even like a hint of orange showing up. I don't know if it can show on camera, but this is what I'm seeing, and it's changed a lot in a matter of 2 minutes. Okay, so we reached our 14-minute mark, and our solution has changed from that little bit of orange that was at the bottom, with the rest of it being this red, to it completely now being this orange or even amber considered color. Yeah. So we've reached now 18.5 minutes, and as you can see, our solution has turned from the orange that was stated earlier into this light yellow, and so we'll see what happens in another few minutes. Okay, so we're close to 28 minutes with this solution, and it is getting pretty clear. It still has this yellow hue to it, but not as yellow as it was the last time that I showed it. It's getting pretty clear, so hopefully in a matter of a few minutes we can see how fast this changes. Okay, so our final time that our reaction 2 has gotten clear was at 35 minutes and 11 seconds, so around a minute to 2 minutes faster, so it's not by too much. And our final temperature is the same as our beginning temperature at 25 degrees Celsius. Okay, so we're beginning reaction 3A with our ice bath. Both of our reactants have had 10 minutes in there. We're at 5 degrees Celsius, so now I'm just going to pour my oxalic acid into my potassium permanganate and begin the process. And put it back in the ice bath, and we'll see what the initial and final temp along with color changes are in a little bit. Okay, so we're at the 12-minute mark, and in our ice bath, compared to our first two, which around the 10 to 12-minute mark you would see some changes. This is still at the same dark purple that it was whenever I put it in, and so it is a significant difference between the first two reactions already. So we'll see what happens as time progresses. Okay, so we're at the 33-minute mark, and usually for the first two reactants, when they would be getting close, if not finished by this point, our solution is still at this dark purple. So it's going to need a lot longer to be able to get this solution, due to its temperature, from the opaque purple state that we see it in right now to the clear, like almost looking like water that we're trying to get it to. Okay, so it's been taking a really long time. At the 57-minute for reaction 3A, we've got it to this amber, like dark orange color. So we're gonna wait a little more longer to see if there's any more drastic changes that show. But this is the biggest change that it has so far in the matter of close to an hour. So it might take even 15 to 30 minutes more to even see another drastic change like this. So, okay, it has been a long time since I've last checked in, but it's at an hour 20-minute mark, and it's showing a lot of significant changes. It was this amber color, but now you can clearly tell that it's this orangish color. It's getting lighter as we speak. And so we'll maybe take about 15-20 minutes and see if this changes to a significantly lighter color, or maybe get clear by that point. So for reaction 3A, we have hit the 3-hour mark, just a few minutes over that. And it is still this orange color. I do not know how long I need to wait for it to fully clear, but right now we're at 3 hours and it's really not changed that much at all. Okay, so we finished with reaction 3A, and this reaction took to get clear. The timestamp is 11 hours and 16 minutes for it to get completely clear, and its final temperature after taking out the ice bath was at 1 degree Celsius. Here it is. Okay, so we have had both of these solutions in this for around 10 minutes, and their final temp separate for our potassium is 50 degrees Celsius, while our oxalic acid is 47. So now I'm going to add this oxalic acid pretty quickly into here so that we can start this reaction. And there we go. Right now it has this very dark purple, but now I'm going to put it and see later how this changes. 30 seconds in to our part B for reaction C, and it is already at this very light orange color. This has gone a lot quicker than any of my previous ones. Yeah, and we'll see what happens a little bit. A minute 30 seconds, close to 2 minutes in, it's already very close. It's this now yellow, almost clear color. We're gonna wait just a little bit longer until it gets completely clear, but this has gone super fast. So it got clear for my hot bath. It got clear at approximately 2 minutes and 56 seconds. It's completely clear, and it completely finished its reaction. That was a lot faster than any other ones, and its final temp, checking it, was at 37 degrees Celsius. Okay, so here we are now at reaction 4. I already have my 4 milliliters of potassium permanganate and 4 milliliters of oxalic acid in their separate test tubes. So for now, I'm going to now add my oxalic acid into my potassium permanganate. And now I'm going to add my 0.5 grams of manganese dioxide into it very carefully. And then once this is added, we will start our time. So yeah, it has been added. And right now, just from initial color, is now black, and it is bubbling. So we'll see what happens in a little bit. So we're at the 34-minute mark for our reaction 4, and I see something very interesting happening. There's still a good amount of it settled at the bottom, but it is clearing out. No matter what I do, it seems to want to settle. Even agitating it brings it back to this state. But right now there's a black ring around the top and some stuff settled at the bottom, and in the middle it's pretty clear, like this smoky gray clear. So I'm gonna agitate it some more, just to make sure that it works the way it's supposed to, but we'll see what happens after some more time. Okay, so our reaction 4 has gotten clear as water, but of course, as you can tell, it has this black cinnamon in it, and no matter what we seem to do, it will not really separate. And so I think this is where we call it for it. And the timestamp was at 1 hour and 30 minutes, and its final temperature was at 24 degrees Celsius. Now that we are done with our experiment, let's talk about what is happening in our analysis. So, the first part of the analysis is to find the rate of each of our reactions. So in our first reaction, which was our control, you do 1 over the time, and I believe that would be time in minutes. That's what I did, and I made sure it was minutes for all of them. And in the end, for reaction 1, it would be 1 over 37, which was 2.70 times 10 to the negative 2 when put in a calculator. For reaction 2, it was 1 over 35, which putting into a calculator would equal 2.86 times 10 to the negative 2. Reaction 3A is actually 1 over 676, because it took 676 minutes, or roughly 11 hours and 16 minutes, in order for the reaction rate to occur. But putting that into a calculator has it be 1.48 times 10 to the negative 3. Then for reaction 3B, it only took 3 minutes for this reaction to occur, so it's 1 over 3, and putting that to a calculator, you get 3.33 times 10 to the negative 1. And then finally, your reaction 4 is 1 over 90. Putting that to a calculator gets 1.11 times 10 to the negative 2. Now going on to our next question about comparing these two reactions. Well, not two, but comparing our reactions that deal with our variables compared to our control. The second reaction, it kind of shocked me a little bit. Reaction 2 was slightly less time than it did for reaction 1 to complete, and which, in my opinion, from predictions, I did not believe that would happen, so I was wrong about that. Then going into reaction 1, our control, versus reaction 3A. Comparing the reaction 3A has a significant difference in reaction rates. The temperature of the solute made the significant change to the reaction rate, and the ice bath was used for this one, and the ice bath significantly affected how long it took, because comparing to your reaction 1, it took 18 times the length, roughly, of reaction 1 for reaction 3A to finish. Now going into reaction 3B, it was a lot faster than I expected. It took around 1/10 of the time that it did for reaction 1 to be done, which made sense. It was a lot faster than I expected, but it made sense, and I predicted that it would go faster than my reaction 1. And then reaction 1 versus my reaction 4. This one was the one that I was the most surprised about, because from what I've looked at, catalysts are supposed to speed up the rate at which your reaction will occur, because it's going to require less energy in order for this reaction to occur. But the complete opposite happened for me. Once the catalyst was added, it actually took 3 times longer than the control in order for that reaction to clear up. And as I already stated, comparing these, most of my predictions in revolving temperature were correct. Of course, the times really did surprise me on how fast it took and how long it took for those two, but ultimately those two I was very correct about. Reaction 2 surprised me because I believed that having a diluted substance would make it so that it would take more time, because there would be not as many collisions occurring between these molecules. But I stand corrected. Even though it wasn't a big change, it was still enough to notice that there was a change in time. And then reaction 4, of course, like I stated before, was the one that surprised me the most, because of the knowledge about catalysts supposed to be taking quicker than expected. It actually took a lot longer. And that is all that I can say for my analysis.